Hello everyone, hope you are doing well. Welcome to All in Maths channel. Today's the lesson is about the area of a circle, sector, quadrant and a semicircle. Join with me. Okay, at first we will learn the area of a circle, semicircle and a quadrant. Actually, I want to tell you that I told at the beginning that we will do the area of a sector of a circle as well. So these are also two sectors of circles. Okay, so I'll explain you what is a sector when it comes to the next session. Alright, now I have a circle with radius r. Can you remember the formula for the area of a circle? Yes? A is equal pi r square. Very good. Pi is a fixed value. So we can take this pi value as 22/7 or as a decimal. For 3 decimal places 3.142. Okay. So it's a fixed value. So radius is the r here. So radius square we have to take. So what is the area of a circle now? Pi r square. Okay, area of a circle is pi r square. So I want to explain you one special thing here. Some children, when they learn the circumference of a circle, which is equal to pi r or pi d, they erroneously apply in the area of a circle also. So which it is wrong, because you should remember area always appears with square units, right? So square units, because area can be taken when you have two diagonals, two lengths. So when you have r into r, it comes to the square unit. Area always appears with square units. So you should not mix up 2 pi r or pi d with pi r square. Okay. So hope you can remember now what is the area of a circle? Pi r square. So tell once again what is the area of a circle? Pi r square. Good. We are coming to the semicircle. First of all, let us know these three theorems and move on to the examples. So area of a circle. If you take the area of a circle, area of a semicircle, it is a half of a full square. If you complete this, it becomes a full square, right? So this is a half of a full square. So we can assume what is the area of a semicircle with this. What should that be then? It is equal half into pi r square. Okay, half times pi r square. So some students write pi r square divided by 2. This is also correct. Both are correct. So that is the area of a semicircle. Then area of a quadrant. Area of a quadrant means quadrant is a part of a circle. Okay. It is cut from the origin and then this part is called a quadrant, part of a circle. So with that you can understand the formula of a quadrant. Okay. So now semicircle area is half into pi r square. Semicircle is a half of a circle. So quadrant is a quarter of a circle. Then quadrant area, what should that be? Yes. If the semicircle is half of a circle and it comes with half into pi r square, quarter of a circle should come with quarter into pi r square. Okay. Quarter into pi r square. So then this into is written or not written, it doesn't matter, because as you know that if there is no symbol in between two letters or a number and a letter, that is the multiplication. So quarter pi r square is also correct, or else quarter into pi r square. So once again, one full circle is equal to pi r square. Half of a circle, half into pi r square. Quarter of a circle, quarter into pi r square. 1/5 of a circle, yes, 1/5 into pi r square. 1/8 of a circle, 1/8 into pi r square. So first you learn these three with the examples, and let us come to the next part when we learn the sector area. Okay, right, the first question. First question, the radius is equal, in the first question the radius is equal to 5.5 centimeters, right? Okay, so I want to find the area of this. Area is equal to pi r square because it's a full circle. So area is equal to pi, you can use the calculator pi value, or else you can use as 22/7 into, what is the radius now? 5.5. Okay, 5.5 to the power 2, right? So what is the answer? Write the answer for 2 decimal places. You calculate this using your scientific calculator and write the answer for 2 decimal places. What is the answer? I have written at first for 3 decimal places because I want to show you the rounding off as well. When I want to have the answer for 2 decimal places, I will be keeping the 2 decimal places and removing the other numbers. And when I check the immediate number, it is less than 5. So I will not add 1 to the second decimal place. So my answer is 95.03. Is your answer correct? Very good. Okay, come to the next question. Look at the next question now. I have given the diameter. Diameter is 24. Can you remember in the circumference you have used the diameter directly? Taken C is equal pi d. But then in area you cannot do that. R square is not equal to d, right? R square is R into R. D is R plus R. So do not mix up, right? So we are moving to this. Once again, the area formula is equal to A is equal pi r square and pi into, what is the radius now? 12. Then 12 square because 24 is our diameter. So diameter divided by 2 is equal to the radius. So what is the answer for 2 decimal places? Please find the answer for 2 decimal places. Okay. So I have written the answer once again for 3 decimal places as to show the rounding off. I want only the 2 decimal places, and then area is equal to 452.39 square centimeters. This square centimeter appears, that is because 12 into 12, 12 centimeter into 12 centimeter, 12 centimeter into 12 centimeter. Centimeter multiplication is square centimeters. Okay. Alright. So now that is about the area of a circle. Now we are moving to the semicircle area. So what is the semicircle area formula? Half into pi r square. Very good. Okay, now we are writing half into pi r square. Half times pi, calculator pi can be used once again, times, what is the r now? Diameter is 14. The radius is, yes, very good, 7. 7 square. So write the answer, you find the answer now and write the answer for 2 decimal places. For 3 decimal places, it is 969, 76.969. And when I want for 2 decimal places, it's 76.97 square centimeters. As we have 9 here, which is above 5, I had to add 1 here when I round off to 2 decimal places. So hope all of you have got this answer. Then the quadrant is there. Okay, what is the quadrant area formula? Area is equal to quarter into pi r square. So quarter times pi is the calculator pi that we use, and then radius is directly given, which is 3.9. So you can use the scientific calculator and find the answer. And give me the answer for 2 decimal places once again. Yes, it's like I have given 4 decimal places for the moment, and then I'm going to round it off to 2 decimal places. Here the immediate number after 2 decimal places is 5. So I have to add 1 here. It is 11.95 square centimeters. Is that very clear to you? Okay, shall we revise? The area of a circle is pi r square, and always area appears with square units. And then semicircle area is half into pi r square. Quadrant area is quarter into pi r square. And the application also you saw now. Let us move on to the sector area. Alright, now we are going to learn to find out the area of a sector. What is a sector basically? What is a sector? We always tell that sector area, sector is appearing in compound figures. So what is a sector? Yes, if you define a sector, is it a part of a circle? Because most of the children say it's a part of a circle. Okay, I'll draw a circle. Okay, and then I take a part of a circle. This is the origin. Okay, origin is somewhere here. Is this a sector? A sector is surrounded by 2 radii and part of a circumference. So that is why I called, although some students say that a sector is a part of a circle, the definition is incorrect. Because any part of a circle is not a sector. Even this is not a sector. It should go through the origin. Right? Origin. That's why we call it should be surrounded by 2 radii. What are radii? Why do I now? Usually from the center to the circumference, the straight line drawn from the center to the circumference is called the radius. Radius. But I told 2 radii. Why is that? R-A-D-I-I. Radii is the plural form of radius. Okay. So a sector is surrounded by 2 radii. 2 radii and a part of a circumference. That means it is cut through the origin. You have to cut like this. Alright? Okay. Now we are moving to the area of a sector. You know that area of a circle is pi r square, a full circle. A full circle area is pi r square. And half of it is equal half into pi r square. Quarter of it is equal to quarter into pi r square. So I have a sector now. This sector, as you feel or as you understand, how can we write the area of a sector? Yes, you can assume. Now assume that your angle is theta degrees and the radius is r. Yes, we can form the formula like this. Pi r square for a full circle. And we have theta degrees only out of 360 degrees. Out of 360 degrees, we have only theta degrees. When we had half, we wrote pi r half into pi r square. So when we had quarter or quadrant, quarter into pi r square. So now I have theta degrees out of 360. So I should write theta out of 360. So this is the sector area. This theta can be 60 degrees, 40 degrees, 120 degrees, below 360 any value. Okay, below 360, 0 to 360 if you take, any value can be here. Okay, now we have some sectors here. I have drawn some sectors here to generate the formula. Okay, so you know that area of a sector is equal pi r square into theta over 360. Here the theta is 20 degrees. So what is the formula? Pi r square into 20 over 360. Then what is the formula for this 310 degrees sector? See, this is all are cut through the origin, right? Through the origin only we have to cut to get a sector. Alright, this is 310 degrees sector. So area is equal, first comes pi r square into, what is the angle? Theta is 310 here, 310 out of 360. Next one, 200 degrees angle. Yes, area is equal pi r square into 200 out of 360. Good. Next one, 350 degrees. What is the cutoff part? 10 degrees. So prevailing one is 350. Area is equal pi r square into 350 out of 360. Hope it's clear to you. What is this? Quadrant. I said quarter into. So we'll check whether it is correct according to this formula. Area is equal pi r square into 90 out of 360 according to this angle out of 360. So we can cut 0 to 0, 9 times 1, 9 times 4. 1/4. Can you remember that we entered pi r square into 1/4? Pi r square into 1/4. This is how it was formed. This is the theory behind. Alright, now you know how to find the formula for any sector. Let us move on to questions. Now I have a 40 degree sector here in which the radius is equal to 9 centimeters. So we will find out the area of this. What is the formula? Area is equal pi r square into theta over 360. This is the general formula. And let us write with our angle. Area is equal pi into, what is the radius? 9 centimeters, substitution. Theta is equal to 40 out of 360. So area is equal. Get me the answer for one decimal place. Yes? Okay. The answer comes, I have written the answer down here for 3 decimal places as to show you how to round off to 1 decimal place. So I will keep 1 decimal place and remove the other numbers. The immediate number is above 5, so I have to add 1 here. So the answer for 1 decimal place is 28.3. Hope all of you have got the answer. Okay. Let us move on to the next question. What is the angle here in the next question? What's the angle? 300 degrees. So this is also cut from the origin. And I want to find the area of this sector. This is my sector, okay? The small part is not a sector, it is the angle angle presentation. This is the way that they have given the angle. This is not the sector, this big one is the sector. So what is the angle now? 300 degrees. So what is the formula for the area of a sector? Pi r square into, very good, theta over 360. Area is equal, substitution, pi is the calculator pi value, and then radius is 15, I have given as 15 centimeters, so 15 square into theta is 300 out of 360. Easy, right? So get me the answer for one decimal place now. Get me the answer for one decimal place. The answer for three decimal places is 589.048. So if I want to get for one decimal place, I am removing from the second decimal place. The immediate value after the line is 4, which is below 5. So we do not add anything to 0. So our answer is 589.00 square centimeters. Hope all of you have got the answer if you have calculated using your scientific calculators. Alright, we are moving to the next question, which is the last of the sector of a circle. No, I have another question. Here 100 degrees is mentioned outside the sector. So most of the time what the students do is, they, as soon as they see 100, they put pi r square into 100 out of 360, which is wrong. You have to be vigilant. Sometimes the questions are a bit tricky, and if we do not pay attention, we will end up with wrong answers. So here 100 degrees is the cutoff part. Cutoff part we should not take to the formula. We have to take the sector area angle. So if this is 100, you should understand that this is 260. Why? I am at a point add up to 360. So this is point. So full angle should be 360. When 100 is taken off, 260 is remaining. So our formula is once again pi r square into theta over 360. So the substitution of values, pi into radius is equal to 16.4 square into, what is the theta value? Let me write this substitution in a different place, somewhere here, so that it will be visible to you more. Pi into radius is 16.4 square times theta. Theta is 260, not 100. 260 out of 360. Please get me the value for one decimal place. Yes. 610.3. 610.3. Because it comes to 610.25. So when I round off, since it is 5, I have to add 1 here. So 610.3 is the one decimal place answer. Okay, this is the last question, which is a compound figure. It is comprised with a rectangle as well as a sector. So when you have a compound figure, what is the method of finding the answer? Better to give them letters. This is the rectangle R, this is the sector S. So we have to find out the rectangle area and the sector area separately and add them. So then you get the compound figures area, the total area. So the easiest one is the rectangle. Let me find out. Rectangle area is equal length into breadth. What is the length? 6 centimeters. Breadth is 2 centimeters. It's 12 square centimeters. Then area of the sector, today's lesson. Area of the sector is equal pi r square into theta over 360. Pi is the calculator pi value once again. Radius is 7 centimeters, 7 square. What is the theta value? 60 out of 360. So get me the answer here. Is it 25.66 square centimeters? Alright. So then total area. Tot A is equal 12 plus 25.66. It comes to 37.66 square centimeters. For one decimal place, it's 37.67, actually 7 square centimeters. Because I'm removing 6, which is above 5, so I have to add 1 to 6. So 37.7 square centimeters is the answer for one decimal place. Okay, let me summarize. We learned area of a circle today. This is pi r square, area of a semicircle. Yes? Can you read out the formula for that? Half into pi r square. Very good. Quarter of a circle, quadrant, area. Quarter into pi r square. Any sector area. First of all, what is a sector? A sector is a part of a circle surrounded by 2 radii and a part of a circumference. So, sector area is equal to pi r square into theta over 360. Theta is the angle given in the sector. Alright, so then according to that you can write any sector formula using the given angle, and you know how to apply in the questions as well. So, hope the lesson is very clear to you, and let us meet on another day with a different lesson. Have a great day.